Hello students, today we are going to learn about geometric progression. So like arithmetic progression, consider a sequence. Let a1, a2, an be a sequence. Okay, then the sequence is in GP, means geometric progression, if a2 by a1 is equal to a3 by a2 is equal to an plus 1 by an equal to suppose r, means fixed. Okay, the ratio of consecutive term is fixed, then the sequence is in GP, and in that case r is called a common ratio. Okay, this is called common ratio. Now looking at this line, if you follow clearly, you can see that a2 is equal to ra1, a3 is equal to ra2, an plus 1 is equal to ran, and so on. Now if you observe clearly, this a2 is okay, fine, but the a2 is again ra2, so you can write it as r square a1, and here an plus 1 is equal to rn a1 is equal to, and so on. Okay, so you can ultimately write any sequence which can be written in the form ar square, ar cube, and ar to the power n minus 1, then this sequence is in GP clearly. Now this is the first term of GP, this is the second term, this is the third term, this is the fourth term, and so on. You can see for term 1 it is a, for term 2 it is ar, means this is 1, for term 3 this is ar square, 3 minus 1, so this is basically 3 minus 1, this is 4 minus 1, so this is your nth term. So general term of GP can be written as, so the general term of GP can be written as n is equal to ar to the power n minus 1. Okay, this is the formula for general term of GP, like we have general term of AP. Next concept is your infinite geometric series. Infinite geometric series. How can you write it as? Suppose we have a GP of ar square, ar cube, ar to the power n minus 1, then so sorry, we have said infinite but finite. Okay, so this is up to this, then a plus ar plus ar square plus ar to the power n minus 1 is called finite geometric series, because we have considered this term as finite. If you consider infinitely many terms, suppose, then we can write plus other terms also. So if the geometric progression has infinite terms, then the geometric series has infinitely many terms in the summation, and if there is only finite terms, means if we neglect this infinite term, then we have finite geometric series. Now the question is, what is the sum of these infinite geometric series, there will be some or you can add. So if you consider this as finite geometric series, then let S is equal to A plus AR plus AR square plus AR to the power n minus 1. Okay, now if we multiply this R with the S, and I can write it as AR plus AR square plus AR cube plus plus AR to the power n minus 1 plus last term is AR to the power n. Okay, and this is your first series, this is your second series. Now if I write 1 minus R, this will be 1 minus R of S, and now if we subtract from 1 all the terms of 2, then we are left with A minus AR to the power n. Okay, so finally we are left with A 1 minus R to the power n and 1 minus R. This, remember, this line is true when this is finite terms. Okay, so this line is true when R is not equal to 1. Okay, because when R equal to 1, the entire geometric series reduces to A plus A plus A up to n terms. So this is nothing but NA. Okay, now for infinite geometric series, n tends to infinity. So if R is equal to 1, then obviously sum is infinite, provided A not equal to 0, which is certainly for a series, because if A equal to 0, then we only have 0, 0, 0, 0. So if R is, suppose we can say like this, if 0 less than R, not 0 less than R, basically suppose if R mod R less than 1, and R is less than 1 quantity, this implies R to the power n tend to 0 as n tends to infinity. Therefore S becomes A divided by 1 minus R. Okay, R to the power n quantity tends to 0 in the summation. In other words, let me go to the initial. This quantity tend to 0, and so we have A by 1 minus R. What happened if mod R is greater than 1, then R to the power n tend to infinity as n tends to infinity. So S tend to infinity. Okay, so finally we can understand this, that summation S can take two values. Okay, this is A by 1 minus R if mod R is less than 1. Okay, and infinity if mod R is greater or equal to. In sequence term, this is called divergent. That geometric series divergent, or geometric series is divergent when mod R is greater or equal to 1, means common ratio is greater than 1, and geometric series converges. This you have a definite value A by 1 minus R, so this is convergent. Okay, now for finite terms we can write in the similar form, that S is equal to a 1 minus r to the power n divided by 1 minus r when mod r less than 1, and it's not necessary, but it's basically not equal to 1, so na when r is equal to 1. So you don't need to write this part. This part is not that important. Certainly r is right, r not equal to 1 is good enough. Okay, so someone write that if less than 1, then we can write, if suppose r is less than 1, then this will be the formula. If r is greater than 1, then you have to replace this by 1 minus. This is not necessary. This will automatically be done while doing computation. This part is not important. Okay, so this is how you can add the geometric series. For other stuff I will make another video. Okay, thank you.